Alright, so in this video we're gonna solve this problem, which is the sliding block with friction. So I have this mass MA that is of, this mass MA that is of 4 kgs and mass B, MB that is of 5 kgs. And as you can see, the mass A is actually placed on mass B. And I'm pulling this mass B with the force F. And the amount of F applied is such that they both, slide together, not like the 5 kg one don't slip uh, out of the system, right? So they actually move together, they slide together. And for the system, for this whole thing to slide together, the force is 27 newtons, right? So we need to find out what is the coefficient of friction, because in the next part of the problem they say that now I'm applying the force here. So what should be the amount of force such that, you see, the whole system moves together? So we can also compare that, it is easier to apply force on the upper box, or it is easier to apply force on the lower box. Well, yeah, so let's write. So yeah, so there is force F. Okay, so on MA. So on MA, as you can see, I'm pulling it like this. So there is just a friction force which will move it. So it will be, frictional force will be equal to M1 XA double dot, sorry, MA XA double dot. And on MB, that will be your force, uh, minus our frictional force equals to MB XB double dot. Now XA double dot equals to XB double dot. So what just happened is that it turned out to be F upon MB minus of small f upon MB equals to F upon MA. This is it. And now we're gonna solve this part, which is, so F is 27 divided by what is the mass of MB, that is, okay, let's not solve it like this. It's going to be just, so I'll write it as F upon MB equals to F upon 1 upon MA plus 1 upon MB. After solving this, we get the answer, get some answer. Okay, so here's the final expression, and rest of the thing is a numerical exercise for you, and you will get mu as 0.3. If you just plug in the values now, you will get mu equals to 0.3. Okay, I think I should do it for that. So F equals to 27 newtons, MB equals to 5, and this is mu times MAG, that is 1 by 4 plus 1 by 5. Okay, 27 by 5 equal to 0 0.8. Okay, this is what I have to calculate, sorry. Mu times 4 times 10 on 1 by 20, this is 9. So yeah, there we go. So mu equals to 0 0.3. And now, since I have got mu equal to 0 0.3, let's move to the next part of the problem. That is, I have the same system, but now the force is being applied here. So, well, it's quite simple again. So F prime is the new force, and minus a frictional force will give me MA XA double dot, and F will just be equal to MB XB double dot, and XA double dot equals to XB double dot. So it will be F bar upon MA minus of F upon MA, and that is equals to F upon MB. So again, I have to calculate this F bar. So that is F bar upon MA equals to F upon 1 upon 4 plus 1 upon 5. That will go as F times 9 upon 20. And your friction force is just 0.3 times 4 times 10, 9 by 20, and yeah, so F bar will be, just a second, bar will be 0.3 times 2 times 9 multiplied by this 4. So it turns out to be okay, I don't think I have made a mistake. I hope that well, yeah, I actually really hope that I haven't made a mistake. But this is 9 fours are 36 to 2, 0.3, yeah, so 72 times 0.3, that will be 21.6 newtons. So here is your answer. Thank you.